So we're going to continue the discussion about trigonometric functions and equations. So today we're going to work with our calculators, solving equations graphically. Now the biggest issue that's going to be here is going to be, one thing is recognizing what is the period for the function we're working with. And the second thing is going to be making sure that you put it in your calculator correctly, because mistakes made by putting it in your calculator incorrectly will obviously cause you problems. So we need to make sure that we do that right. So there are two types of trigonometric equations: identities, which will be studied more in chapter 9, and are equations that are valid for all values of the variable which the equation is defined, such as the Pythagorean identity, sine squared plus cosine squared equals 1, and cotangent equals 1 over the tangent. In this chapter, conditional equations will be studied. Conditional equations are valid only for certain values of the variable, such as finding when sine of x equals 0, cosine of x equals 1/2, or 3 sine squared of x minus sine of x equals 2. So one of the things we will be doing also is, this last question reminded me, is we will be doing some factoring in this chapter also while we're solving equations. So when we're solving them, any equation involving trigonometric functions can be solved graphically. To solve trig equations graphically, the same methods of graphical solutions are used here as they have been previously to solve polynomial equations. In my Algebra B class today, I spent some time with just simple linear equations, showing how to find them with our calculator. And they're like, well, these are so easy, why do we need to do that? And I said, you need to learn the basic ones so that when they get harder, it won't be as difficult. Except that trigonometric equations typically have an infinite number of solutions. Now, that just reminds me of the test, that there were two different questions where you had to answer similar to this, where you were solving them. One of those questions had a limit from 0 to 2 pi, the other one didn't. So one of them you should have put plus 2 pi n for your responses, the other one you should not have. So if you did, I was nice, I only took 1 point off. If you didn't put 2 pi in when you were supposed to, I took 2 off. So, okay. All right, so here's some basic trig equations that we're going to solve. First one, number 1, we're going to solve this using the intersection method. Okay? So put tangent of x in y1 and -1 in y2. And, anybody know what mode we should be in? You should be in radians. Okay, so now is where it gets really tricky with your calculator. Okay, you always need to make sure you're in the correct mode when you're doing these. Right? So make sure you're in radians. Tangent of x and -1. Now, we're actually going to look at this with our graph, but you should know what the answer to that is. Okay? It's not 0. Anybody know what it is?
Like 2 seconds.
Gallery? It's not -pi over 2. 3 pi over 4 could be our answer, and it would be 3 pi over 4 plus pi n, because tangent and cotangent only have a period of pi. Or you could use any of them. So one of the things we will look at during this chapter also is the fact that I could use -pi over 4 plus pi n. That would work also. All right, let's look at it graphically then. Now, so what am I going to put on my calculator then for my window? What window should I use?
I use
Zoom 7? Okay, so let's look at Zoom 7 and see what we get for a result there. Now, that's okay, right? But I have one concern, okay? And the concern is recognizing the period. We need to make sure we know what the period is, because when I put plus such and such n, that has to be whatever the period is, correct? So what would be a good window so I could really tell what the period is? Okay, so from, okay, negative 2 pi to 2 pi, that's okay, but it'd be better if we went from like 0 to 2 pi. So let's try 0 to 2 pi for our x. So we look at this graph. We know the graph is tangent, but we also know that for tangent, the period is equal to pi, right? Okay. So we can see that from this graph, that it intersects at 1, or negative 1, in 2 places. Okay. Well, what do we know about these 2 places here? Okay. What? Okay, they're exactly pi away from each other, right? Okay, so we need to figure out what the first, doesn't matter which one we use. Actually, it doesn't matter which one we use, okay? Normally we use the one closest to 0, so if we do our second trace, find the intersection point, number 5. Okay. Here's my first curve. Notice it's y1 tangent of x. Second curve then is at pi and y equals negative 1, so hit enter there. Now, I have a question for you. How come it went to that point there first? Anybody know? When I first hit enter for intersection, why did it go there first? Because it's in the middle, exactly, okay? All right, one of the things that the graph is always going to do when you hit trace or you hit anything that involves trace is that it's going to go right to the middle of the graph, the x-axis right away. Okay? So there's our second curve. Now, there's 2 intersection points it could go to, right? Well, the main thing is it's always going to go to the one you have closest to it right away. So if I needed both of them, I'd have to do one and then scroll over for the other one. Since it's closest to this first one, I can hit enter there, and we get 2.3561945. Right? Except we know the answer is what? What is this the same as? 3 pi over 4. Okay? It's the same as 3 pi divided by 4. Okay. So in this case, my answer will be 3 pi over 4, the x equals plus pi n, where n is an integer. Okay, so there's the intersection method. What's the intercept method? Because a lot of times the intercept method is actually easier than the intersection method. Look for x-intercepts. So if we're looking for x-intercepts, then what must be true about this equation? Has it equal 0. So my first step then is going to be to change this to sine of x minus 0.33 equals 0. Well, okay, so let's graph this then. So we got sine of x minus 0.33. Now, make sure you close your parentheses, because some of you seem to think that that was a horizontal shift there, but that's a vertical shift. That's not horizontal. Why is that not horizontal? It's outside the parentheses, okay? So, all right, so we're going to use, almost always we'll use 0 to 2 pi. That helps us with our establishing what the period is for sure. So here's our graph. And the other thing is, if the period is 2 pi, then how many intersection points am I going to find? Or whichever ones I find, I can just take, I need to use all of them then, right? If the period is 2 pi. So we have two different answers here we're going to use. Now, when we talk about using the intercept method, you can do it two ways, okay? You can either do the find the 0, okay? Or if you would rather put 0 in here in y2 and find the intersection points that way, I don't care, okay? Because some of you probably find this much easier than the other way, and that's fine. It doesn't matter to me. But the intersection method, or the intercept method, where you're looking for the x-intercepts, is usually going to be easier than the intersection method, because sometimes when the graphs are going all over the place, and you have a lot of different places where it happens, it's easier to see the zeros. So second trace. If you want to find the zeros, this is how you do that again, number 2. Okay, so I've got 2 zeros I'm going to find. So I actually want to come over here to the first one. And now one of the things to remember is when you're doing this is just like with trace, you know I can put in any number I want. I can do it here too. Because it says find the left boundary. Well, my left boundary could be, this goes by pi over 2, right? My left boundary could be 0. Okay, you can see it flashing there. All right, I can type in the number I want for the left boundary. The right boundary then, well, let's see, it goes by pi over 2. Does anybody know what the decimal is for pi over 2? It's 1.57, and that's important that you know that 1.57, 3.14, was it 4.71, okay, and 6.28. Those four numbers are important ones to know. The fact that there's pi over 2, pi, 3 pi over 2, and 2 pi. Right? So I could put in 1.5 here for my right boundary, because we know that's approximately pi over 2, which would be where this increment is here. Right? I can hit that. Right? And my guess is going to be between them, and I get 0.336. So there's one of my intercepts. So now I'll do the other one. I'll find the second one here. Well, I know that's between pi over 2 and pi. So second trace, number 2. My left boundary could be 1.5, approximately pi over 2. My right boundary then, which is on the other side of that 0, would be pi, so that's 3.14. And so I'm on the other side of it. Click enter, and we get 2.805. So here it shows my two answers. So my answer is going to be x equals 0.336 plus 2 pi n and 2.805 plus 2 pi n, where n is an integer. So you use the method that's easiest for you. But the one thing is that you're probably most of the time going to want to use the intercept method, find the zeros. It's usually a little bit easier than the intersection method, just because sometimes it gets a little confusing. So here you go, solving trigonometric equations graphically. Number one, here it is right there. Write the equation in the form f of x equals 0. So we're going to find intercepts. Determine the period of the graph. Graph it over an interval of the length of the period. So basically what they're saying is find the period. Once you find the period, then use that number as your max, okay, for your x max. Use the calculator zero finder to determine the x-intercepts, and then we're going to write it in the form u plus kp, where k is an integer, or np, whatever, but p stands for the period. All right, so let's look at number 3 here. Solve 4 cosine squared x plus sine of x minus 2 equals 0. Now, first of all, we need to talk about how do I do it when there's an exponent, because we've got to make sure that we type things in correctly for exponents. So let's just go to your home screen on your calculator for a moment. And I want to do, let's see, what will be an easy number? I don't know. Okay, pi over 3. What's the cosine of pi over 3? 1/2, right? Okay, what happens when I square 1/2? What do I get? 1/4, right? Okay. All right, so let's take cosine, and we're going to do the cosine of pi over 3. Now, I want to do this 2 different ways. First of all, now we're going to square it, okay? Let's see what we get if we put our squared sign here, number here. Okay. All right, we got 0.25, right? Okay, we're good there. Okay. All right. Now, here's the thing I want you to understand, is that when I write it out, and I write the cosine squared, I put the 2 between there, right? After it's cosine squared of x, like it's written there, okay, or cubed, or to the 4th power, whatever. When you put it in your calculator, you can do it this way. It squares the whole response. In this case, it does not just square pi over 3. If I wanted to square pi over 3, then I would have to put a second set of parentheses here and square it. Okay? All right, that would square pi over 3 instead of squaring the cosine of pi over 3. Okay? So we need to make sure we put it in correctly. So we're going to type this into our calculator then. So when I put it in my calculator, I've got 4 cosine of x squared plus the sine of x minus 2. Make sure you close your parentheses so you don't end up with horizontal shifts that aren't supposed to be there. Okay. So what's the period of cosine? 2 pi. What's the period of sine? Okay, so what do you think the period for this function is going to be? Okay, roughly 2 pi. Probably 2 pi. All right, so let's graph it from 0 to 2 pi and see. Do I know that that's what the period is then? We don't, do we? Okay, so let's check it. Let's start at negative 2 pi and see what happens. And see if I get the exact same thing twice. I think 2 pi is supposed to be my period, but I'm not sure. Okay. So did we get the same thing? Okay. So we can focus on just between 0 and 2 pi then. It's just that when I write my answer, I'm going to say plus 2 pi n. Well, how many answers am I going to have? What's that? Goes on forever. I'm going to have an infinite number of answers, but how many answers am I going to write down on my paper? 4 of them. Okay? I'm going to write down 4 of them because since the period is 2 pi, none of these are going to match by pi or by 3 pi over 2. Okay? They're all individuals. Okay? So if you're sitting next to somebody, then one of you get 2 of them and the other one get the other 2. Okay? Or if there's 3 of you sitting next to each other, have person in the middle get 2 of them and the people on the outside get 2 other ones from there, so you can match them. So you're not all doing all 4 of them at the moment. You know 4 of them? Did you do all 4 yourself? Okay. So you should have 1 plus 2 pi n, 2.139 plus 2 pi n, 3.776 plus 2 pi n, and 5.648 plus 2 pi n, where n is an integer. Okay? For all 4 of them. So if you get used to what these numbers are, the fact that we've got pi over 2, pi, 3 pi over 2, and 2 pi, you get used to those numbers, then it's easy to pop in those numbers in there also if you want to do, if you're doing the finding the zeros instead of just doing finding the intersection point. Okay? All right, so look at number 4. It says tangent of x equals -4 cosine of 2x. So the first thing we're going to do again is we want to get it all on the same side of the equal sign. So we're going to add 4 cosine of 2x to both sides. And then we need to discuss what is the period. Now the period for tangent is what? It's pi. Okay. The period for cosine is 2 pi, but here this says the cosine of 2x. By putting that 2 in front of the x, what does that do to the graph of cosine? Okay. Compresses it by 1/2, right? Which means the period for cosine of 2x is what? Pi. All right. So if I graph this from 0 to 2 pi, I should see the same thing 2 times. Okay, so let's try it and see what we get. So do we see the same thing twice? Okay, it starts up here at this max value, comes down below the x-axis, and back up. Then it comes down, starts from negative infinity, comes up to that max point again. And then it repeats that. So the period is just pi. So I can narrow my window down to between 0 and pi. And just focus on that graph. Now, why does the graph look like this? What is that? Why is there a gap there? Because of tangent, right? Because tangent is undefined at pi over 2, so there's going to be a vertical asymptote there. Okay? So now we just need to find these two zeros here, and then I'm going to say plus pi n instead of 2 pi n. Oh, and you got the third one. Yep, so we got 3 answers here. So find those 3 answers. Now this is a case where I'm not going to be able to just type in all my numbers. I'm going to have to go to find that spot that's in here to where it's a 0. I see that. Go to the left of the 0, go to the right of the 0, and my guess. So 0.974 should be the first one. Okay, so we should have 0.974, 1.28, and 2.459 plus pi n. Okay. All right, so you guys do this one. Okay. Now, what did you just say, Allie?
You have to change it to degrees.
Yeah. Okay. Here they want our answers in degrees. So you got to change your mode to degrees, which means you're also going to have to change your window to match degrees. No. What's the period for cosine in degrees? 360. Okay. 360. Going to be 90. If you change your mode to degrees and hit zoom 7, what's the one we just did? So 0 to 360, and then 90 is going to be our increments then. X. Still putting X in your calculator. I'm listening, Gio. You didn't square the 3 cosine of X. When you write your answer, it should be theta equals 136. And you can do 1 decimal point for these instead of the 3 that we've been doing. Plus 360n and 223.9 degrees plus 360n, where n is an integer. Yep. Yeah, they actually all are. Thank you, Allie. Just remind me, make sure you're using approximate and not equals because it's not the exact value. Yes, Kayla. You didn't get that. Okay?